Good morning, Internet. I'm Matt Buyak, and this morning I'll be solving the 6th problem on the Project Euler.net problem archive. So yesterday we solved this problem using C and C++. Today I'm going to be taking a look at an analytical solution. You may recall we were asked to find the square of the sum of the first 100 natural numbers and the sum of the squares of the first 100 natural numbers, and to find the difference between them. Now, in a previous video, the first one I think, in fact, I talked about the equation for the sum of the first n natural numbers. So for this part of our problem, we can just use that equation and square it, and that gives us that number. The equation that I haven't talked about yet so far in this series is the sum of the squares. Now these are referred to, the sum of the integers here are referred to as the triangle numbers. The sum of the squares are referred to as the pyramid numbers. And we could easily Google that and find the equation, but then this video would be about 2 minutes long and wouldn't be particularly enlightening. And so I thought I would take a look at why the equation for the pyramid numbers is what it is, and also do that derivation. So let's get into it. So open up, yes, we've already created our problem directory in the previous video. So let's just open up our analysis file. And I'm actually going to make use of some high-tech graphics here. We have MS Paint. So before I get into why the pyramid numbers are what they are, I want to take a look at the triangle numbers just as a stepping stone to getting to that point. So let me just draw up a simple diagram here. Let's suppose we have something like this. I'm just putting together a little diagram. All right, so so here we have our sum of the integers 1 through 6, basically. So here you can see it's 1, 2, 3, 4, 5, and 6, and the area of this shape is the sum of the first 6 natural numbers. But we actually have a formula for the area of a triangle that we can use to derive the equation for the triangle numbers. If we look at this triangle here, and this is in fact where the triangle numbers get their name. Let me just color this in. So the area for this triangle, you probably remember from grade school, is just going to be the base times the height over 2. And so for a quick approximation of the triangle numbers, it's just going to be n squared divided by 2. And so we can note that in our analysis file here. So we might say triangle numbers. Main triangle is just going to be n squared divided by 2. And so then in order to find an exact expression for the triangle numbers, we just have to look at, let's see here, we'll color this in blue. So these sections here, we just have to find the area of those and add that in to get our equation for the triangle numbers. And you'll see that each of these has area 1/2. And so that's just going to be n over 2. So we can go back to our analysis. And we'll just call those blue edges. And that's going to be n over 2. And so then we can just add those together and we get, n squared over 2 plus n over 2. That's going to give us, n times n plus 1 over 2. And that's, in fact, the equation for the triangle numbers. So if we wanted to expand this to look at the pyramid numbers, their name already gives a hint for where we're going to be going with this. Unfortunately, my artistic abilities are not strong enough to actually draw you a three-dimensional pyramid, but you might imagine, if we're looking down at a pyramid from above, what that might look like. And in fact, just as here we're only actually drawing, 1/2 of this. If you can imagine this as being the cross section of a pyramid, we're actually only drawing 1/2 of it here because that's what's useful for our purposes. And so similarly, I'm actually only going to be drawing 1/4 of what you might think of as being sort of a classical pyramid shape. So you can imagine if we're looking down at this pyramid from above, we've got this at the base, this square that's 5 by 5, and then on top of that you have stacked this square that's 4 by 4, and then 3 by 3, 2 by 2, 1 by 1. And so the volume of this pyramid shape is going to be 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared, which is our pyramid numbers that we're trying to calculate. And so as with a triangle, there's also a simple formula for the volume of a pyramid. And I think most folks have probably forgotten or maybe never learned this one, but for a square pyramid, it's just going to be 1/3 base times height is the equation for that shape. And similarly, though it's more difficult to draw in this diagram, we're going to have a similar arrangement as when we were calculating our triangle numbers, where we have this equation for sort of the inside shape that's at the core of our pyramid here. But you've got these little edges that we're going to have to add in. So let me just divide the regions of this triangle up a little bit more and color code those, because there's actually one more case that we're going to have to deal with here. So in particular, these corners that you see me separating from the rest of the triangle, those are going to have to be calculated a little bit differently from the rest of the pyramid. And so I'm just going to color code those so that you can easily see what I'm talking about. Let's see. So we colored the edges here blue, so we're gonna use the same convention in our pyramid. So those blue edges, if you imagine this to be a cross section of the pyramid, that's just going to correspond to these shapes right here. And then now you can see clearly what I was talking about, that these corners are going to be calculated a little bit differently than the rest of the pyramid. And so we'll color those in green. Okay, so just to summarize where we're at so far, we're going to start with our pyramid numbers. And the main pyramid, which you can't actually see in my diagram, it's hidden inside the triangle or the pyramid. But as I stated, that's going to be n cubed over 3, because that's base times height over 3, and the base is n by n, and the height is also n. So that's going to be n cubed over 3 is the volume of the main pyramid there. So then if we go back to our diagram, you can see these blue sections. So in the cross section here, we can see that those all have, the cross section has area 1/2. And so the total volume of those pieces is going to be the area in this diagram times 1/2. And you can see that this is mirrored. So you got 1, 2, 3, 4 here, and 1, 2, 3, 4 there. So we can just find the area of 1/2 of this here, and that's going to give us the volume of those blue edges. So if you look at these sections here, you see it's 1 by 1, 1 by 2, 1 by 3, 1 by 4, etc. And so the area of those sections in total is actually just going to be our triangle numbers that we calculated previously. The one caveat is that we're actually starting at 0 rather than starting at 1, and we're ending at n minus 1 rather than counting all the way up to n. And so that changes our equation for that slightly. But let's see if we add, say, blue edges. That's just going to be n times n minus 1 over 2. And so just to double check, in this case, we have 1 plus 2 plus 3 plus 4, so that's going to give us 10. The total area is twice that, 20, but then each of these has a cross-sectional area of 1/2, so our total volume is going to be 10. And if we plug 5 into our equation here, we end up with 5 times 4 over 2, and that gives us 10. So that matches our expectations. So now we just have to calculate the volume that we have to add to these green sections here. And you might notice that each of these green sections is actually the same shape as the entire pyramid. That is the red idealized pyramid on the inside of our shape here. And that is, it's going to have a volume of 1 by 1 by 1 divided by 3. And so in order to bring that up to a full 1 by 1 by 1 cube, we need to add 2/3 to each one of these. And we can see that there are going to be n such corner pieces. And so we can add green corners is just going to be 2n over 3. And so adding up all 3 of these, we should get the total volume of our pyramid. Just to clean things up a little bit, you'll notice that these two have a denominator of 3. This has denominator of 2. So just to clean things up a bit, I'm going to change those all to have the same common denominator. So that's going to give us 2n cubed plus n minus 1, 3n times n minus 1, plus 4n all over 6. And then we can just distribute that out, and so we're going to have 2n cubed plus 3n squared plus n over 6. And so that should be our equation for the pyramid numbers. And we can check that really quick if we just try 1 squared plus 2 squared plus 3 squared plus 4 squared. I believe that gives us 30. I did that right. Yeah, I think that's right. And so then plugging in our equation, that's going to be 2 times, so our n here, just note this, n is going to be 4. So that's going to be 2 times 64 plus 3 times 16, so that's 48, plus 4 divided by 6. And so then we can do 128 plus 48 plus 4 divided by 6. And that gives us 30 as expected. So now that we have our equations for both the triangle numbers and the pyramid numbers, we should be able to calculate the solution to our problem. As you recall, the larger of the two numbers is going to be the square of the sum. So the sum is going to be n times n plus 1. Again, we're doing n equals 100. So it's going to be n times n plus 1 over 2. And we're going to square that. Minus the sum of the squares. That is the equation for the pyramid numbers that we just got. So that's going to be 2n cubed plus 3n squared plus n over 6. And so now it should just be a matter of plugging and chugging. So we'll have 100 times 101 divided by 2. Square that. I'll say minus, let's see, 2 times 100 cubed plus 3 times 100 squared plus 100 over 6. All right, so we get 25,164,150. And so then if we go back to the archive here, we'll see that does indeed match our expectations. So for the next video, I won't be going directly on to problem number 7. If we go back to the list of problems here, we'll see that problem 7 involves calculating large prime numbers, and that's a little bit outside our capabilities in terms of programming at this point. So I'm going to do a video just on calculating prime numbers before we move on to that problem. So if that sounds interesting, then check that out.